The FAA is in the process of updating the arrival and departure flight procedures at Raleigh-Durham International Airport. The new flight procedures will allow aircraft to more safely and efficiently enter and exit the airspace surrounding the airport. This project is part of the FAA's nationwide strategy to modernize the entire airspace system and meet the future demand at busy airports like RDU. In recent years, RDU has continued to grow and serve the Raleigh-Durham-Chapel Hill region. Businesses, leisure travelers, and cargo shipping all benefit from having a nearby international airport. As a result, the local economy has grown and, in turn, air traffic at RDU has increased. In 2019, RDU averaged more than 600 daily arrivals and departures, with 10 major airlines serving 14.2 million passengers and shipping over 100,000 tons of cargo. This video provides information on air traffic control flight procedures, including background on why we make changes to the airspace, what is a procedure, and how are they modified. This video will provide specific examples for Raleigh-Durham International Airport. The National Airspace System is a three-dimensional structure in the sky that allows controllers to manage the safe and efficient flow of aircraft between airports. Many of the pathways leading to our busiest airports are old and inefficient. By building new and more predictable flight paths, we can improve the safety and efficiency of the operations in the airspace and on the airport surface. The creation of performance-based navigation, or PBN flight procedures, is one of the key elements of modernizing our airspace. A PBN flight procedure is a route through the sky that connects airports to airports, safely segregates air traffic, keeping flights clear of obstacles and terrain, and provides safe passage through the skies. Creating and publishing a PBN procedure in the National Airspace System follows a well-defined, multi-step process that begins with a specific need, benefit, and purpose. A team of air traffic professionals, operators, airports, and other aviation stakeholders contribute to the design of a procedure. Historically, airports were constructed based on the prevailing winds, with aircraft departing and landing into the wind. RDU has 3 runways. There are 2 primary runways oriented northeast to southwest, which are parallel to each other. The 3rd runway is shorter and is oriented from northwest to southeast. In Raleigh-Durham, the prevailing wind direction varies throughout the year. About half of the time, winds favor a northeast operation, and the remaining half of the time, winds favor a southwest operation. When the wind is generally coming from the northeast, aircraft land and depart to the northeast, flying into the wind, using runways 5 left and 5 right. When the wind is generally coming from the southwest, aircraft land and depart to the southwest, flying into the wind using runways 23 left and 23 right. The new PBN flight procedures are for departures and arrivals on the 2 primary runways. The 3rd runway, runway 1432, is rarely used because it runs perpendicular to the primary runways and is much shorter. Therefore, it is only usable by small aircraft and helicopters. In complex and busy airspace such as RDU, controllers continually manage, space, and separate arrivals and departures throughout the day. Modern technology and procedures make that job more safe and efficient because the separation requirements can now be incorporated within the procedure. Departures will have the most efficient routes off the ground, reducing airborne delays such as holding patterns or speed reductions. Departures and arrivals have numerous crossing routes where aircraft separation must occur to ensure a safe and efficient operation. A traditional descent is like walking down a flight of stairs. Based on air traffic controller instructions, the pilot descends and applies speed brakes, then levels off and powers the engines up, then descends and applies speed brakes again. The cycle repeats itself until the plane is on final approach to the airport. By contrast, an optimized profile descent, or OPD, has built-in speed and altitude requirements at various points on the route. This information is programmed into an airplane's flight computers and allows them to essentially glide down to an airport on idle power, and controllers don't have to issue instructions after clearing the plane to begin its descent. To fly an OPD, the aircraft must be placed on a single precise path starting from cruise altitude all the way to landing on the runway. This is like driving a car from a highway to an exit ramp and then a neighborhood street, but seamlessly and without stopping. By placing an aircraft on a continuous, predictable path, it is procedurally separated from all other aircraft in the area that are arriving and departing at the airport. Such a path is the safest and most efficient possible route and can be used during periods of low traffic volume. PBN arrival and departure procedures were introduced at RDU about 10 years ago. However, these procedures are not being used as published due to crossing altitudes and speed restrictions, and some aircraft are not able to execute the current approach procedures as designed. Therefore, the FAA is planning to implement 4 new PBN arrival procedures, 12 new approach procedures, and 7 new departure procedures. These new procedures will replace all of the existing procedures at the airport. The new arrival procedures will take effect once aircraft have started descent from cruise portion of the flight. They will provide stabilized descents, remove level-offs, and allow for near-idle approaches. Jet aircraft will follow the same general flight path used today from the beginning of descent to approximately 6,000 feet in altitude. Each arrival procedure consists of segments that guide the aircraft to land on a particular runway. The last segment is the final approach, which consists of the final few miles where an aircraft is lined up with the runway. At RDU, 12 approach procedures will be updated. 4 of them will continue to use the traditional ground-based navigational aids, while the remaining 8 will use precise satellite guidance using PBN technology. The new departure procedures will follow the same flight paths used today to take off from RDU, then exit the local airspace. The new PBN procedures are designed to remove airspace conflicts, resulting in less leveling off during the climb, which is more efficient and can reduce noise exposure levels. They are designed to work in tandem with the arrival procedures at RDU. Departure aircraft typically remain under the arriving aircraft. These changes will ensure safety and separation standards are maintained where these routes cross. This video provides a basic understanding of how the air traffic control system works in the Raleigh-Durham airspace and how and why the FAA is modernizing the national airspace system. The new PBN procedures at RDU are expected to be implemented in February 2021. For more information about this project, visit the FAA's Community Engagement website.